Alrighty, so problem given to us is 4p minus 50x squared equals 1600, and this is the equation given to us, and our problem is so suppose the quantity demanded weekly of super titan radial tires is related to the unit price by the following equation, where x is measured in units of thousands and p is in dollars. The question is, how fast is the quantity demanded weekly changing when x equals 16, p equals 60, and the price per tire is increasing at a rate of $5 per week? So we're going to be asked how the price is changing per time or the quantity is changing per time. So some keywords you want to look for is increasing, which is positive, and decreasing, which would be negative. So we have a quantity that's related to tires that's asked for in this equation. So again, the question is asking is how fast the quantity demanded weekly changing. So changing is a derivative. So when x is 16 and p is 60. So let's go back to the price. Quantity demanded weekly changing. So when quantity is x, you want the derivative of x with respect to time. So it's going to be dt. So how fast is the quantity changing with respect to time? And we want to know that when x is 16 and p is 60. And the price per tire is increasing at a rate of $5 per hour. So rate would be dp. So let's write this down. X equals 16, p equals 60, dp over dt, which is the rate, equals 5. So let's remember the equation, and we have to use implicit differentiation like we have done before. So it would be 8p dp over dt minus 100x over dy dt should equal 0, because this might be a big number, but it is still a number, which means it's a constant, and that would equal 0. So we don't have anything canceling out so far. So we're going to take this and we're going to solve this equation for dx dt. But first we're going to substitute in our values in the appropriate places. So p is 60, so it's going to be 860. And dp dt is 5. And that x is 16. Okay, we don't know what dx over dt is, so it stays. So now that we have this, we're going to subtract from both sides, and I'll erase the top part. Okay. So when it's all put together, it is 2400 minus 1600 of dx over dt equals 0. Now we're going to subtract 2400 from both sides, so it's going to be negative 1600 dx over dt equals negative 2400. Let's just erase this now. And now like we've done so before, we want to divide this number right here. So divided, so we're going to have dx over dt, which equals negative 2400 divided by negative 1600, which equals 3 over 2, or 1.5. first of all, you need to know that, well, remember that X is in thousands, and this was a quantity that was being demanded or produced, which means that X is changing with time in a positive direction, but because it's in thousands, you want to use 1.5 and multiply it by 1,000. So you'd be able to like see it. So it'd be like, so 1.5 times 1,000, which is 1,500, which means it's increasing at a rate at 1,500 tires per week. Okay. So to expand further on this question, or just to have a different way to a new question, same equation. Right, so now the question is, how fast is the weekly supply of super Titan radial tires being introduced into the marketplace when X equals 8, P equals 108, and the price / tire is increasing at a rate of $4 per week. So let's erase this. So all of this is dx dt when X equals 8, P equals 108. And then we have the price per tire, which is increasing at a rate of $4. So price per week equals $4. Remember, that's positive. If it was decreasing, we'd put a negative sign. So this is very similar to the last example. So we're going to take the derivative. We're going to take the derivative of this equation. Oops. I forgot the equation changed. Oh no. Different equation now, guys. Alright, so the equation is 2p minus 3x squared equals 24. So now we're going to take the derivative of this equation, which is 2 dp over dt minus 6 dx over dt equals 0, because again, this is a constant. Derivative of that is 0. So if we remember correctly, dp over dt equals 4, so it's 4 minus 6x, and x equals 8 dx over dt equals 0. So this is 8 minus 48 dx over dt equals 0, and now we subtract 8 from both sides, and we're left with negative 48 dx dt. You see, dx dt equals negative 8, and then remember we divide by this, so dx over dt equals negative 8 divided by negative 48, which equals 1/6 or 0.1666. Alright, and with that we conclude implicit differentiation of real life applications. I hope you learned something.